Hi everyone, this is Arfeen, and today we are going to calculate value at risk. So let's start. First, we are going to import libraries. So import pandas as PD. So instead of importing in this way, what I'm going to do is I'm going to import all the libraries in a single line of code. So import pandas as PD, numpy as np, pandas underscore data reader as web, from scipy import stats. Also we need to import a library for graphs. So matplotlib dot pyplot as plt. Let's run this. So in the meanwhile, let's write a code for data. So data is equal to web dot data frame. We need a stock name, data source, Yahoo. We need start date 1/1/2020. We need end date, which is 12/31/2020. We need adjusted closing price. Okay, let's run this. Okay. Oh, it's supposed to be data reader. Once it will download, so we will check the head of the data. Okay, so we are going to calculate return. So what I will do, return is equal to, here we are going to calculate log return. So for that, we have a code np.log data apple divided by data apple dot shift -1. What this line of code will do actually, it will calculate a daily return, today's price divided by yesterday price, which is basically -1. So let's run this. Let's again check the data. Okay, so we have daily return of Apple. So we need to calculate value at risk. So for value at risk, we need volatility, confidence interval, and we need time. So this is the formula of basically, actually it should be square root of time. So this is the formula of value at risk. We need to calculate volatility. So for vol, what I'm going to do is return dot std. It will be our daily volatility. So let's check the vol. So it's 2.94%. Okay. And we have confidence interval. So let's say is equal to stats dot norm dot ppf 0.99. So what I'm doing here, I'm taking 99% confidence interval. So what would be the value of 99% confidence interval? Let's check, 2.326. Okay, and time we can put it in the formula directly. So let's calculate VaR. So VaR is equal to confidence interval, which is 99%, multiply by daily volatility into np dot square root sqrt of, let's say, 1 day var. So let's run this. Okay, so we can also multiply it with 100. Okay, so this is our var, a daily var at 99% confidence interval. We can increase number of days here. Let's say 10-day var. See, okay, 21.63. So now I'm going to calculate value at risk by using a user defined input, and it will be like, so for example, we have CI, which is confidence interval. So I'm going to ask from user to input the data at any time whenever they are going to run the code. So enter the confidence interval. I'm also going to ask from the user to input the time. So input. Here I am doing some mistake which I will show you in a while, because if I will right away put the right code, so in future if you are going to use input function, so you could do the same mistake which I'm going to do now. So enter the time horizon. Okay, let's run this. So my confidence interval is 99 and my time horizon is, let's say, 1 day. Okay, let me do it in this way so it will look more presentable. 99 and 1 day. Okay, so I'm going to use the same line of code where I'm going to put value at risk is equal to. So what I'm going to do here is I'm going to calculate CI is equal to stats dot norm dot ppf and CI. Okay, I'm also leaving one more thing here, and then time is equal to np dot sqrt of time, which is basically the input here. And then we will have a value at risk formula. So we already have volatility here. We can calculate it here. We can calculate it in another line. That's perfectly fine. There is no issues. So since everything is here, I'm going to copy this and paste it here. So it will look more decent and good. Okay, so what we have here, let's say vol into confidence interval into time, multiply by 100. So let's run this. Now, mistake number one. Perfect. So if you can see here, it's 99, and we should give or provide a confidence level or probability in the range of 0 to 1. So what I'm going to do here is I'm going to divide it by 100. Let's run this. 99, 1. Now there is one more mistake. What I'm going to do here is, because if I'm going to input anything, it will take it as a string. So I'm going to assign this number which I am putting as an input as a float. So let's run this. 99, 1. Okay. Similarly, here I'm going to put int. So I think there must be one question coming in your mind, that why I'm putting float here and why I'm putting integer here. So confidence interval could be 97.5, 95.5, 99.9, whereas time cannot be in decimal. So that's why I'm putting it as an integer. So it will be 1, 2, 3, and so on. So let's run this. 99, 1. Oops, I didn't print value at risk. Perfect. So let's print it in a presentable form. So print the value at risk of Apple is curly braces dot format value at risk. Let's run this again. 99 1. Okay, so let's put it in two decimal place. So it will be 0.2 floating, and let's put it in percentage. So 99 1. So the value at risk of Apple is 6.85%. Uh, we can also, it doesn't look good. So I'm going to say confidence interval, time horizon, and print a line and then 99 1. Okay, so the confidence interval is 99, time horizon 1 day, and the value at risk of Apple is 6.85. Let me show you one more thing. So 97.5, 10 days. Perfect. So this is working properly. Since we are putting or assigning a number in floating, so it will give us the right result what we are expecting. Okay, there are some small things which I wanted to share with you. So let's count the data sets. So I'm going to see the data information here, and the data information we have here is Apple stock price was 253 while return is 252. While we are calculating, or we usually calculate value at risk for 250 working days. So for in this case, what we need to change, we need to only change the volatility. So what we can do is we can calculate vol underscore 250 days is equal to data return of, so we have 252 days. So what I'm going to do, I'm going to say start from 2 and end up to the last number dot std. Let's run this and let's check the vol. 2.954%, while the volatility here was 2.94. Okay, so we need to see the exact number of days that are we taking the right numbers or not. So I'm going to copy this line of code and paste it here and say count. So we have 250 number of data point or 250 data point. So, okay, this is one part. So in order to calculate volatility of 250 working days, all I need to do is I need to put 2 here. So what this line of code will do, it will calculate the volatility of only 250 working days. So let's run this and 99 1 6.87%. So we can also do it in terms of amount. So let's say we have an amount of, let's say, again, I'm going to do the same thing, 0.2 floating and USD dot format value at risk multiply by, let's say we have invested 100,000, 99 1. Value at risk of Apple is 6.87 percentage in terms of percentage, and in terms of amount, the value at risk of Apple is 68720, which is 68,000 prox. So in the last video, I put some comment here that we need to divide this value at risk by 100. Why? Because we have multiplied it with 100 just for presentation purposes. So what I'm going to do is I'm going to divide it by 100 in order to have a correct number. So let's run it again. 99, 1, and here we go, the correct calculation. Now, so what I'm going to do this time, I'm going to calculate historical VaR. So since we have already calculated historical VaR here, but I want to calculate a historical VaR on a daily basis for like let's say last 2 or 3 years. So how I can do it? Let me download data here. Data hist is equal to, let me copy the code for downloading the data so it will remain same. Let me copy it and let me paste it here by Control V. So here I have downloaded this data from 2020. So let's say I'm going to download this data from 2018 or let's say 17. No worries. Let's run this. Okay, let's check the data here. Data dot head. Okay, check the data from another way. So let's say data underscore hist dot info. So I'm checking the data information here. So we have only one column, which is Apple, contain 1700 data point, and the type of the data is floating. Okay, we can also do some other statistics like data hist dot describe. Okay, so the total data is 1007, mean is 56, standard deviation 25, minimum 27, maximum 136. This is percentile. So you have in different form. So what I did here, I just take the transpose. So in Python, all you need to do is you just need to add dot t and you will have a transpose data. Okay, let's start our analysis. Let me add some line for codes. Okay, and then data hist. I need to calculate return. So is equal to np.log data hist apple slash, just to save some time, I'm going to copy this. So it's gonna be data hist and the rest will remain same. So let's run this. Oops. Let's check data again, data.head. Also just check the tail of the data. Perfect. Now we need to calculate volatility. We need to calculate, in order to calculate basically VaR, we need to calculate volatility and it should be daily volatility. So for that, what I'm going to do is I'm going to calculate data host historical vol, which is volatility. And then all I'm going to do is we have data host return dot. Now we need to calculate a daily volatility here. So for that, what would be the formula for calculating the daily volatility? It will be your rolling period. So what I'm going to do here is rolling. We need to calculate a daily rolling 250 working days volatility. And then I gonna say STD. Let's close the bracket and then that's it. Now let's check historical data dot head. Okay, so you will find nan. Let's check the tail. Here you go, the historical volatility. So it's a daily historical volatility of Apple from 2017. Uh, okay, so I'm going to do one more thing here. Let's, okay, I'll do it here, no worries. So as mentioned earlier, so we are going to have some chart, we are going to have some historical VaR calculation, some analytics. So let me show you some chart. So data historical return dot dot plot. Okay, so we have a return chart, return series here. Okay, so we need to, let's say I'm going to say kind is equal to line. It's gonna show you line. I want, let's say I want to increase the size. So it's gonna be fixed size equal to, let's say 8 comma 8. So run this. Okay, I gonna say let's make it 15 here. Okay, now we have a return series here. I want to see that it is normal or not. So data hist return dot plot kind is equal to histogram. Okay, I want to say bins is equal to, let's say, 100. Okay, I'm going to increase the size as well. So fixed size is equal to 15 comma 8. Let's run this. Okay, so we need to have a line here as well. So for that, what I'm going to do is I'm going to import one more library called Cbon. This is specifically for charts. Okay, so SNN dot, let's see how many chart we have here. Algorithm, axis, bar plot, blend plotty, box plot. So many options you will find here. Here we want historical oh sorry, histogram chart. So what I'm going to do here is histplot, and then let's see what are the information required in order to make a chart. So we need to provide data, we need to provide X, we can provide bins, although it's auto, but we can provide it as well. Okay, so let's do it. Data is equal to data hist, X is equal to return. Okay. Now both the charts are similar. So what I'm going to do is I'm going to say bin is equal to 100. Let's run this. Perfect. Now we need a normal distribution line. So in this one, KDE is equal to true. Here we have a line as well. We need to change the color of the chart. Color is equal to green. Oops. Okay. I can change the color as well here. So you can increase the size, and what I would recommend you to search how to increase the size, and if you are unable to find it, just put it in the comment section below, and I will guide you how we can increase the size of this chart by using Seaborn, not from pyplot or sorry, matplotlib, pyplot here, or from pandas. So yeah, okay. Now I'm going to do one more thing here. In fact, I'll do it in a later stage with VaR. So, okay. So what I have done so far here, I have calculated historical volatility. Now, let me just grab the data here. So, okay. Now I'm going to calculate historical VaR. So let's say hist underscore VaR, which is equal to, so we have historical simulation or historical data here, in which we have return series. Oops, sorry, it will not be return, it will be historical volatility, because we need volatility for calculation. Multiply, we need confidence interval into to time. I'm going to multiply it with -1, which I will show you in a while. In fact, I'm going to remove it, and then I will show you why I'm doing this. So let's run this. Okay, so CI and time is already defined there on top, which is confidence interval and time. So in this case, I think I have to change it to, instead of capital CI, I'm gonna make it, in fact, I'm gonna put confidence level and horizon. Let's run this and you will find an error. So, okay, sorry, it's gonna be, I'm gonna put it like this way. It's gonna be good. Okay, so confidence level is not defined. So for that, what I'm going to do is, so there are two options. Number one, you can define confidence interval here directly and time horizon in order to generate a series. Another way is to just input the data, and then it will auto add your confidence interval and time, because every time, for example, if you want to check the historical value at risk on 99% confidence interval with 1 day horizon, you will generate only one series. If you want to change the confidence interval from 99 to 27 by having the same horizon, so your data will append the old historical VaR. So that's why I'm defining historical VaR here. Now, if you want to have a multiple VaR, so that's a separate thing. For that, you can have historical VaR at 99%, historical VaR at 97%, historical VaR at 90%, or whatever confidence interval and horizon you want. So in this case, since I have defined confidence interval and horizon, so what I'm going to do is I'm going to input. So for that, I'm just going to copy the same command which I have put it here. So let me just copy and paste by using Control V. So CI. So here it will be, let me copy this confidence interval, horizon. So here I'm going to put, let's say CI, let's say days, and I'm going to remove this. So the same thing should be reflected here. It's gonna be CI and it's gonna be days. So let's run this and see 99 1. Now I want to see historical data dot head. Let's run this. Okay, now we have a new column which is called historical VaR. Let's check the tail of the data. Perfect. I want to see data information. So data info. Let's see. Okay, so now we have Apple, which is 1007. We have return, which will be always less than the actual price. Obviously, the first day return will be 0. Then we have historical volatility. I will show you something in order to just prove the calculation of value at risk, which is historical VaR. I'm gonna take the last. In fact, I'm going to multiply it with 100 and I'm going to take the tail. So you will see um okay. In fact, I can do it directly, but let's try this as well. Okay, so it's negative 5.88. So what was our number here, which we have just calculated before? It is 6.87%, while this is quite different. I need to check why. Okay. So basically it's gonna be horizon here, and let's run this 99 1. Okay, 5.88 same. There must be something I'm doing wrong here. Uh, let me do it here. Let me run this one and see what's gonna happen. So 99 1 6.87. Uh, uh So wall is basically it's gonna start from second, and okay, one more thing I need to fix here, which is confidence interval, confidence level. I hope it's gonna sort out. Yes. So that was my mistake because I didn't change it. So now it's 6.87%. Perfect. So hence we have proved that the last observation is also matching with the 1 year value at risk which we have calculated above, which is this one based on almost 1 year data. So yeah, let's plot this. So what I'm going to do, data historical dot plot. Let's plot this. Okay, so here we have Apple price, we have return of Apple, we have historical volatility, and we have historical VaR. All we need to do is we just need to plot two things, which is return and value at risk. So for that, what I'm going to do is let's plot it one by one. So let's delete this. Oops. Return dot plot. Okay. Let me just increase the size. Is equal to 15 comma 8. Let's run this. Okay, perfect. Now this is the return we have. Now we are going to calculate data or plot basically historical var dot, let me copy this whole. Okay, so if you remember, I told you that we are going to multiply it with -1 in order to have a chart which gonna start from negative axis, because value at risk is always negative. It's a loss actually. So yeah, what I'm going to do here is multiply -1. So let's run this. So we have a number in negative, gonna be loss. Okay, so here you have noticed that 250 working days is blank because we calculated 250 rolling volatility. So in order to remove this, we have another way. So I'm going to show you how we can do it. So if you remember, we did one thing here. We started our data from 2. So for that, what I'm going to do is we need to plot this data, especially return data from 250 working days. So what I'm going to do is data historical. Now, here is the tricky part. What I want to do is I want to calculate, or I want to basically plot it with the starting point same as VaR. So for that, what I'm going to do is I'm going to take historical VaR dot count minus 250, because 250 is the rolling days colon. Let's run this only and see how many data point we have here. So we have 500 data point. Okay, in fact, I can remove it here and then see how many data point we have. So we have 250 because the remaining data is 250. So all I'm going to do is minus, let's say 500 and then see how many data points, 750 data point here. Uh, and if you notice here, the total data point is 757. So what I'm going to do is I'm going to start this from 507. So let's see. So it's gonna be 557. Let me just show you one more thing here. Let's say 509. We have 579 return series, which we don't want actually, because we want it to be the same. So 570, 757 here, and 757, which we have already noticed. Where it is here. That the historical VaR figure is 757. So what I'm going to do here is dot plot fixed size is equal to 15 comma 7. Let's run this. Okay. I think let's make it 8. Perfect. And then I'm going to plot data hist historical var. Copy this, paste it here. Great. Now this is based on line. Now I'm going to do some small modification in this chart. So kind is equal to line, but what I'm going to do here is I'm going to say style style is equal to, let's say I want dots. Let's run this. Okay. I want the color is equal to red. Now here it's not clear what is what basically. So I'm going to say plt dot legend. So I want to see the name of the data series. So it's return. This is historical var in blue, and I'm gonna say plt dot show in order to get rid of this line. So let's run this. Also, you can change this font style here, actually not font. So I'm gonna say I want plus. Let's run this. You will have plus. You can put any of the sign here, whatever you want.